Hi everyone. So in this video we are going to discuss this Leetcode problem of the day. It is going to be a screencast solution of the problem of the day, which is restore the array from adjacent pairs, and it is a medium level problem. So let's just see what the problem is. There is an integer array nums that consists of n unique elements, but you have forgotten it. However, you do remember every pair of adjacent element in nums. Okay. Sure. So I've understood the problem statement. So this is something from today's Leetcode problem of the day, this rough work. So let me just move it upwards. And essentially what they're trying to say is, if this is the answer 1, 2, 3 and 4, they say either this pair has been given to us or this pair has been given to us. So in this case it was 2, 1. So let me just remove this, and then 3, 4 and then 3, 2. So something has been given to us like this. So if we consider it as a bidirected edge, like this, so you see it has already been given to us, we just need to find this array. Now we can either start from this particular element or this particular element. You will realize both of them will have in degree equals to 1, right? Their in degree of the first and the last element is equals to 1, and for all the middle elements it is going to be 2. So if I know this element, are all the elements distinct? Yeah, so here it is written unique elements, so that is good for us. We don't have to think much. What we can do is we can start from any one corner. Let's say this side, we know its in degree was 1, so we started from here, so the first element can be 1. Now I can go to this particular element and say, okay, you have an element 1 to the left, you can remove it and get me the next element. So if I remove one of them, the only other would be the next element after it, right? So I can pretty much try to continue this chain and form my answer. So let me just create a map of set of integers. So this is going to be my graph, and I'm just going to go in the adjacent pairs vector, and g of I of 0 dot insert g of I of 1, right? And similarly g of I of 1 dot insert I of 0. So I'm just creating a bidirected edge. Let me also create a in degree vector or in degree map. So this is going to be in degree. I'm just going to increment the in degree of both of them, right? Now I can take any element with the in degree equals to 1. So I'm just going to traverse to this in degree vector or in degree map. If I dot second is equals to 1, start, my starting element is going to be I dot first, and I'm just going to break from here. So I'm just going to create vector and answer is equals to start, and let me just also have a queue. So now you will see why I took a set here. You will see in a while. It has a very interesting use case. While queue is not empty, right? So I'm going to take my current node as queue dot front, and I'm just going to pop it, and instead of inserting it here, I can just push back here answer dot push back node, right? Now I just going to traverse for all the vectors for auto child in g of node, Now after pushing it, q dot push child, I'm just going to erase the current node. G of child dot erase node. So what this essentially does is, if I am at currently 1, I have a connection to 2 and 2 has a connection to 1 and 3 as well, right? So I am trying to remove this particular edge. So whenever I try to find the children of this particular 2, I only go to 3, right? So this is obviously one way of doing it. Since all the elements are unique, you can also use some kind of visited map or visited vector, where you can say, okay, I am currently at 2, 1 has already been visited, so I only need to visit 3. Right, this is another way of doing it. So in my approach, what I'm doing, if I'm maintaining a set, the only reason of using a set here was so that I can remove these elements. Now, if I'm currently at 2, I have already removed this particular child of 2, so I'm only going to visit 3 now. Right, so this was the only logic. I have erased the current node, and that is it, I believe. So I'm just going to return my answer from here. Let me just check this. So we use a queue, but we did not declare it. So yeah, this works for sample test cases, and let me quickly check this. Yep, this passes all the test cases and the solution is correct. Although you can obviously improve its efficiency by removing this set and using some kind of other solution. So that's great, this solution works, and I hope that you guys were able to understand the solution. So let me just quickly explain this once more. So I can just move it to the left. So basically what I'm trying to do is, let's say we have been given the pairs like this, right? So we have this pair information. I can either start from here and I can either start from here, right? So no matter where from where I start, both of them are correct. But one common property in both of them is the end degree of both of the corners is going to be 1. So I'm just trying to take one element which has a end degree equals to 1, and I'm going to mark it as start. Once I know the start, let's say this is the start element, right? Now what I do, I just find the adjacent element to it, right? So it is going to be one of the elements which is adjacent to it, which I have already stored in this particular graph. Right, as soon as I find this element, what I do, I remove this particular child, or I remove this particular edge, right? So why am I removing this particular edge? So that the next time when I explore the neighbors of this particular node, I'm only going to get 3, not 1, right? So this is one way of doing it. The other way of doing it is maintain a visited map and mark this particular node as visited. So visited of 1 is going to be true, right? So when you see that 1 is already visited, you are not going to visit it and you are only going to visit 3, right? So this is another way of doing it. In both of the ways, you are going to traverse the whole list in one direction, and then you are going to have these nodes in here and push it back into your answer vector. So this would be the solution of this particular problem. I hope that you guys were able to understand the solution. And for more such videos, you can consider dropping a like on this video, and don't forget to share thoughts in the comments. Because what happens when you engage with these videos, YouTube understands that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today, and I hope that you guys were able to understand this. So until the next video drops, keep coding, stay safe, bye bye.